Thank you very much. Thank you very much. It's nice to be here with you. Let me just do some preparation. So you should be able to see my screen right now. Just can you confirm?
Yes.
Perfect. So as you can see on the slide, my name is Piotrowski, and that's a pleasure to be here with you. Thank you very much for the invitation. I work for VMware on behalf of the partner as part of the professional services team. Currently, especially with VMware Cloud Foundation as a product, because that's something which is recently my area of expertise. I'm VCDX 291, so quite a freshly minted one. You can find me on Twitter. You can find me on my blog. Just in case you want to stay in contact after the session, I'm more than happy to answer any questions or have a good chat, good discussion. So that's just a few words of me. I work with lots of various VMware products, and especially that's even forced currently with VMware Cloud Foundation. As you will see in a moment, if it's your first exposure to VCF, you will see that it's nothing completely new. It's just the next level, how we want to do the infrastructure, how we want to build a software-defined data center. And based on that's the topic. So building in an automated way, modern software-defined data center. So that's just me, that's the topic. And just to give you an idea of what we are going to talk, my agenda is quite packed. But first of all, I would start basically explaining you why we bother. So how VCF can help us, how it can make my life, let's say, better. So what's the use cases? And also a little bit about the architecture, day 2 operations, which is a huge use case for VCF, some topologies, and a few words about the lab. I'm using my own lab, but there are some other ways, just in case someone is interested, how you can implement in an easy way VCF in your lab environment. And also at the end, I will just share some tips and tricks from my recent experience working with customers. So just in case you are jumping into some deployments or designs for you or your customers, you will know what you should pay attention to. So first of all, one of the challenges that we are experiencing, if you work as an administrator or a system integrator, consultant, architect, you probably know that it's not so easy to deploy even a greenfield environment right now. If it's only vSphere, then probably fine. But as soon as we start adding additional pieces to the picture, basically we are aiming to build entire software-defined data center, and it's going to be more and more complicated. There are more and more checks that we need to do. I have to see, is my vSphere going to work with this version of NSX? Maybe not. In order to help you with that, VMware is providing something called VMware Validated Design, which is a standardized architecture design. And that's something which is recently quite close to me because I work as a solution architect. And that's also something that I was doing as part of my defense for VCDX certification. So that's basically a reference. You can treat it as a reference architecture. However, it doesn't mean that we can use it for every single deployment, every single engagement. Every environment is different. Every customer will have different requirements. So this is just like a guide. But this is just a guide. It's not going to do the deployment for you. It's not going to patch the environment later. But VCF can do that. VMware Cloud Foundation is also based on those, let's say, proven practices. But on top of that, it's going to add additional layer, which helps us automating various different tasks related to the infrastructure. Because our goal is to build software-defined data center, and we don't want to spend time patching our environment. We want to provide value to the business. We want to satisfy business expectations. And the business wants the environment that's stable, resilient, but they don't necessarily want us to spend time and look at it this entire day. So plus those tasks, to be honest, they are quite boring. If you consider updating, upgrading the environment, checking compatibility. That's not the most sophisticated task that I would like to spend my time on. VCF is going to solve those problems. It's based on well-known, mature products, which all together creates our software-defined data center. So we've got compute, which is powered by vSphere. We've got storage, which is predominantly powered by vSAN. It doesn't mean that you are locked to vSAN. We will talk about that in a moment, but that's another pillar in the software-defined data center. And yet another is the networking. So we've got all pieces together that create our secure, fully automated software-defined data center. As a basement or as a foundation for VMware Cloud Foundation, we've got the bill of material. This is the first key advantage, I would say. The bill of material for every version of VMware Cloud Foundation, currently we've got 4.2, you've got a complete list of components that were tested, and you are getting the guarantee that as soon as you will deploy it all together, it's going to work, providing the highest level of availability, resiliency, and also performance. And you don't need to do, the most important, you don't need to do it yourself. You don't need to go to the hardware compatibility list. Hardware compatibility list you still have to some extent, but you don't need to go to interoperability matrix and check your different products, both at the beginning, during initial deployment, but also later when you do an upgrade. Because if there is a new version of VCF released in the future, let's say, I don't know what the number will be, maybe 4.5, you don't need to check interoperability. You are just follow the process, which will be also automated. So we can say that your role is going to click next, 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 and that's it. And your environment is up to date. So some key values, just briefly, we are getting standardization, which is very important in especially, I work with lots of different customers. Some of them are huge environments. They've got multiple data centers. So if we build every single data center separately, if we've got separate procedures in each of them, it's like, having multiple companies, because that's different processes and so on. We don't want that. We want to standardize everything, because if something is standardized, we know how it should work. If something even doesn't work as expected, the troubleshooting is going to be much, much easier. Another significant advantage is automation. Again, we don't want to do boring stuff. We don't want to repeat the same tasks all and over again. If you did any upgrades of vSphere, NSX environment, you know that the process is more or less the same, but it's quite painful. We need to plan it. We need to know what's the procedure, because from time to time, the procedure can change. The procedure might be different for various products. So we update vCenter this way, we update NSX another way. For this one, we download the OVA. For this, we download ISO. For another product, we just connect to some external repository. So automation of those tasks, and basically that's going to take this burden from us, and we don't need to even know the procedure. We will get one single procedure in a moment, you will see it, where we are going to update all our pieces, all those pillars and components with a single flow. Scaling the environment, both scaling out and in, is super easy with VMware Cloud Foundation, because all the configuration will be automated. So the only thing that you need to worry about is to prepare the hardware, connect it to the network, connect it to the electricity, make sure that it has an IP address that we can reach it. But even this part can be automated. And the most important, lifecycle management, updates, upgrades, patches, all that stuff. But also, so here we are talking about day 2 operations, which will expand in a few moments. We will go even deeper. But another thing is the initial deployment. Let's just consider how much time you need. Let's say You've got a brand new environment. You build a greenfield deployment. You've got 50 servers, a few racks, some storage. So what you have to do, rack those servers, connect them to the network, cable them, connect to the network, install ASXI hosts on each of them, then configure, again, each of them. If you've got 50, 50. If you've got 100, 100. Then the next step, assuming we are deploying the entire software-defined data center, would be to deploy vCenter, connect those ASXI hosts to vCenter, then maybe configure vSAN, the NSX, and do all of that. How much time is it going to take? Maybe, depending on the scale, a week, few weeks. If you need some further planning, even more. With VMware Cloud Foundation, what we are going to do is to prepare the infrastructure. And VMware Cloud Foundation, something that I want to emphasize, is a greenfield deployment only at the moment. So we need to satisfy some requirements, which we will discuss in a second. And as soon as we've got those requirements in place, mostly a starting hardware, and the starting hardware is at least 4 ASXI hosts. You've got them installed with the expected version, which comes from the bill of material. So you are not checking it. You just use the version which is mentioned in the bill of material. You prepare those 4 ASXI hosts. You go over the deployment checklist, making sure that the DNS names are configured, NTPs in place, that you've got various different networks for vSAN, vMotion management, and so on. So you go over the checklist, make sure that all prerequisites are met. Then you will introduce a component called Cloud Builder. Cloud Builder is a virtual appliance that you can deploy anywhere. It can be on either existing infrastructure, it can be on your notebook. Very often when I do some deployments for customer, I just have it on the VMware workstation installed or deployed as a virtual machine. I just connect my notebook to the customer's infrastructure, and I don't need to deploy it in the custom infrastructure. That's something, this is an appliance that I call one task appliance or one task VM, because the main role of this appliance is to kick it off. It's to build my environment, do the initial build, which we call a bring up. As soon as we've got this appliance, there is also something else that we need to do. Of course, there is no magic. Cloud Builder will not know what's the IP addresses, what's the networks we want to use in particular environment. So something that we have to do is to prepare a small document, which is an Excel spreadsheet. It can be JSON file. If you want to make it easy, you can use Excel spreadsheet, where you put all those informations. Networks, temporary passwords, IP addresses, fully qualified domain names. That's it. This file will be loaded to the Cloud Builder, which is going to do the magic. It's going to do the job that ordinarily you would have to do manually. It will connect to each of those 4 ASXI hosts that you just initially installed. They are just installed with IP address configured, SSH enabled, nothing else. It will connect to each of them. It will configure them. It's going to deploy vCenter, configure vCenter, enable vSAN, configure these groups, prepare everything. Then it's going to create clusters, or in the meantime, it will create a vSphere cluster, enable, configure vSphere HA, DRS. So everything that we normally do during the deployment of new infrastructure. Then it will move forward. It will deploy the second pillar for us, which is, or the third pillar, which is NSX. And again, the same story. It will not only deploy NSX managers, it will also configure them, create NSX manager cluster. It will add all ASXI hosts as transport node to NSX. It will even deploy edges, configure routing. So basically, once you start the task in Cloud Builder, you start the workflow, you can go for a lunch, maybe a little bit longer, one and a half hour, and when you are back, you've got full up and ready environment that you can just further expand. So this time, of course, depends on the performance. Usually, especially when I work with all-flash version of vSAN, it takes for me like 1 hour, 20 minutes. So I go for a longer lunch, maybe I walk, and then I don't have to worry about anything. Assuming all prerequisites are met, I've got full environment up and ready. And this part that we are creating here by the Cloud Builder is called a management workload domain. In VMware Cloud Foundation, we use the concept of workload domains, which is a little bit more than a cluster. So you can compare it to a cluster, but that's more than that, because behind a single workload domain, you might have multiple clusters. And the intention of the workload domain is you can find various different use cases. So the first one, the management workload domain, is intended, it's based on 4 ASXI hosts, and this is the smallest number of hosts that we need for VCF. In order to start the journey, you need 4 ASXI hosts at least. That's the minimum, let's say. But then you can create either additional clusters in this workload domain or additional workload domains. That's going to be called something like standard architecture. And that's the preferred one. So we are basically separating the management stuff from our workloads, production, tests, maybe containers, maybe something else. So we work on the workload domain level. In the management workload domain, we will have at least 4 hosts, and that's the resources which are going to keep our management staff. And here from the design perspective, I will mention it also at the end, but that's something that we need to consider while designing the environment. You need to take that into account, that we need the management piece. You need to size those resources, because that, if you follow the standard architecture, that's going to be dedicated to the management staff. So in this management cluster, in the management workload domain, we will have something that's called SDDC Manager. I will talk about that in a moment. That's another appliance. But also vCenter, NSX managers, NSX edges for the north-south communication. All those pieces can be deployed automatically. And optionally, we might have other components from the vRealize suite portfolio, like vRealize automation, operations, log insight, network insights, workspace ONE access. Those components, also the deployment of those components and partially the configuration will also be automated with VCF. So I can create a fully functional environment with technically without even the knowledge how to deploy or vCenter or NSX. I don't need to know it. I need to know what's the prerequisites. I need to know what's the data expected, what's the input, but that's it. And I mentioned the concept of workload domains. Initially, always we will have one management workload domain, which is going to rely on at least 4 ASXI hosts and will keep the management staff. But we can expand our environment by adding additional workload domains. Whenever you add additional workload domain, there will be always new vCenter server. So that's our building block. A workload domain means there will be a dedicated vCenter server for those ASXI hosts which are managed by this workload domain. What's the use cases for additional workload domains? There are many. For example, for some customers, we are doing different workload domains based on the SLA requirements. We divide them tier 1, tier 2, tier 3. So there is different hardware, different teams are responsible for that. We create workload domains also based on the workload type. So maybe in the first one, so here those bluish kind of servers, the second workload domain, maybe we are running Horizon desktops. Maybe that's production workloads, maybe tier 1 workloads. Maybe I need some other workloads to run containers. I can create another workload domain. I can put it as a cluster in existing, but I can create another workload domain, which will, as you can see, the number of vCenters on the left side are increasing whenever we create a workload domain. The number of NSX managers can increase, but doesn't have to, because we can either dedicate an NSX manager per workload domain, or we can make it shared. It depends on your requirements. That's some details that we have to specify and make some design decisions based on requirements, constraints that we've got for particular environment. But basically, the workload domain is our building block in VCF. We manage them, or we create them in an automated fashion. So those additional vCenter servers that we bring with any additional workload domain, they are deployed automatically. We are not going to do it manually. We just add host. This process is called host commissioning. And then we create the workload domain specifying whether we want shared or non-shared NSX, dedicated one, what type of storage you want, is it vSAN, is it something else, and the process will be automated. And one thing to mention, because that's something that I'm asked very often by customers, is, okay, but if we deploy additional vCenters, so who's going to pay for the license? Because usually customers are consolidated vCenters because we have to pay for additional instances. In VCF, you don't have to worry about that. You just pay for vCenter once. Doesn't matter how many workload domains you will create. As long as it's part of VCF environment, you will pay for only one vCenter, and you might use up to 15 in a single VCF instance. Another aspect that's quite important is the storage choice. VCF, as I said at the beginning, is based on VMware validated design. It's a standardized architecture. And because it's a standardized architecture, and because we want you to follow those standards, there are some design decisions which are fixed, which means you cannot change it. So you are going to follow it. There is no way to deviate. There are hundreds of design decisions that you can adjust based on your requirements, but there are some which are, we call them fixed design decisions. One of them is the number of hosts in the management workload domain. You need at least 4, not 3, not 2, at least 4. You might have more, but not less. So that's something that we need to be aware of. Another such fixed design decision is the presence of vSAN in the management workload domain. In VCF, we distinguish two types of storage: principal storage and supplemental storage or secondary storage. In management workload domain, as a principal storage, you need vSAN. This means that the hardware, on my diagram, you probably noticed that it was listed as vSAN ready nodes. You don't need to use vSAN ready nodes. That's probably preferred because it's going, again, even further, make your life easier because you don't have to worry about the hardware compatibility then, but it doesn't have to be vSAN ready node. It can be anything that's compatible with vSAN and vSphere. It can be VxRail. It can be vSAN ready node. But the fact that's mandatory is vSAN. On those 4 hosts, you need to have vSAN. On your other workload domains, you can use whatever you want, but on those, it must be vSAN. However, maybe you need some other storage. That's a very typical scenario. Maybe I need a second tier for maybe for backup, maybe basically second tier for some templates, other stuff. We can connect any other storage that's supported by vSphere. So we can add iSCSI, NFS, virtual volumes, fiber channel, whatever. As a secondary storage, you can add anything you want. When it comes, so that's the management workload domain. When it comes to additional workload domains, which are called virtual infrastructure workload domains, there are also some rules that we need to follow. And those rules are a little bit more relaxed when it comes to storage. You are not limited to vSAN. I prefer to use vSAN for other workload domains because then I've got even further standardization, but it's not mandatory. So maybe you've got existing existing fiber channel storage array. Maybe you've got NFS, maybe you've got virtual volumes. And here on this slide, we are just missing VMFS. So just imagine that there is a fiber channel VMFS because it's supported. In the principal storage, for other workload domains, currently the only storage type which is not supported is iSCSI. But for any kind of workload domains, you can use iSCSI as a secondary storage. So the main rule that I would like you to remember is that in management workload domain, we need vSAN. In other workload domains, you can decide. But that's important, again, from the design perspective, because I work with various different customers, and sometimes they are not aware. Sometimes they bought some hardware which is not following the rule because they had existing storage, they wanted to use it. Great, we can do that, but still we need a piece for the management. Another thing and another component is something new, something called SDDC Manager. SDDC Manager is a component that's introduced purely in VCF environment. I call it Infrastructure Manager. It's going to sit on top of our infrastructure, above vCenter servers, because basically it's going to cover all of them. If you've got 1, 5, doesn't matter. All of them are going to report to the single SDDC Manager. Moreover, SDDC Manager is the component that we will use to run all type of workloads related to infrastructure. For example, you want to expand the infrastructure, you want to add a new workload domain, you use SDDC Manager. You want to add a new cluster, or you want to add new hosts to existing cluster, you use SDDC Manager. You want to update the environment or install patches, you use SDDC Manager. SDDC Manager will also be used to further deploy some other products, directly or not directly, and I mean in vRealize products. SDDC Manager will be used to deploy vRealize Suite Lifecycle Manager and further other vRealize components like Log Insight, automation, vRealize operation. Plus, it will be used for day 2 operations, updates, but also some tasks which are maybe not so pleasant to do. And not sure about your experience, but usually when I work with customers, changing passwords or especially replacing certificates, so self-signs to custom certificates, that's something that everyone tries to avoid. Because usually there is a mess. There are lots of problems. The procedure is different for every single product. So for VROPS, we do it this way. For vCenter, that way. There is a certification manager tool. For NSX, yet another way. Nobody wants to deal with that because it's quite easy to break it. Certificates are quite sensitive, especially. With VCF, SDDC Manager will take this task from us. We can integrate SDDC Manager, for example, with Microsoft CA, and we will have a streamlined, automated process to replace certificates for all our components. And the only thing that we'll have to do is to click a few buttons. One button to generate certificate signing request, another button to get it signed, and yet another to replace. Doesn't matter whether we are talking about vCenter or NSX or whatever. The same consistent procedure. Exactly the same approach we are using for lifecycle management. You don't need to know how to update vCenter. You don't need to know how to update NSX. You just need to know where this option is in SDDC Manager. You will connect, preferably, you will connect SDDC Manager, if it's possible, if it has direct access, directly to VMware Depot. It's going to update bundles. First of all, it will notify you that there are new updates available. You should review them. Okay, this is something that we want to go. So let's make the decision. Next week, we are going to update it. Maybe in the meantime, we will check the hardware compatibility. You just schedule those updates for next week or whatever time you prefer based on your cycles. And SDDC Manager is going to do the rest. You don't even have to worry about the order. You don't need to know that vCenter should be updated before ASXi host and for example, NSX should be updated before vCenter. SDDC Manager will force you to follow the correct order. Again, I don't need to be an expert right now in order to do that. I still need to understand it, but I don't have to follow all the changes that happened over the time. And as I said, SDDC Manager will also help us with other products in VMware portfolio from the vRealize suite. SDDC Manager will call out a process that's going to deploy vRealize Suite Lifecycle Manager. So we go to SDDC Manager, click deploy. Of course, we'll need to provide the IP address or the DNS, but the entire deployment will be done automatically. So you click deploy, go for a quick break. When you are back, vRealize Suite Lifecycle Manager is deployed, and you can further deploy other vRealize components, operations, login, site automation, and they will report back to SDDC Manager. So SDDC Manager is aware of them. And if you want to enable syslog collection that's going to point to vRealize login site, there will be just one checkbox that you will mark on the entire workload domain. Doesn't matter whether there is 100 ASXi hosts, one vCenter and 100 ASXi hosts, or whatever, it's going to be done just like that. That's going to save you a lot of time. Plus, it will force the environment to stay consistent. Because if there is some deviation, you will be usually informed about that, and you need to make sure that the environment stays consistent. If it stays consistent, we've got the standard, we follow the standard, we are going to make sure that it works as expected then. And in case of questions, because I see that something is flowing on the chats, I will address all of them at the end. So keep them coming. If there are any questions, we will get back to it, or Ramandir will help me and answer some of them in the meantime. But if something is not addressed, we'll get back to it.
Yeah, I'm trying my best to answer whatever I can, but I'll leave the ones which I cannot for you towards the end.
Yeah, perfect. Great, thank you very much. Some topologies that are related to other design decisions. Depending on your requirements or your customer's requirements, you might decide to go either with a single VCF instance. Single VCF instance doesn't mean a single vCenter. So in a single instance, you might have multiple workload domains with multiple vCenters. Or maybe, based on your RPO requirements, there is no data loss accepted, and you decide, based on that, the best fit is going to use a stretch cluster. Sure, here you go. You've got maybe 2 availability zones. I've got customers who are doing it across different locations or across, even in the same location, across different server rooms. I've got customers who have only one location, one building, and they do the stretch cluster between data center or server room, I should say, on the ground floor and the first floor. Why not? That's going to, if it's satisfying your requirements, that's the best choice then. Something new in VCF 4.2 is that now we can connect remote clusters. In the past, it wasn't possible, so only those clusters that were deployed by VCF with SDDC Manager were allowed. Now, if you've got the case that maybe there are multiple branch offices, you can use it as well. The stretch cluster scenario is quite interesting, but it's not necessarily going to satisfy all your requirements. For RPO 0, it's going to be a good fit, but what with disaster recovery? Stretch cluster is not going to cover disaster recovery because usually those 2 data center server rooms are going to be close to each other. So if there's natural disaster or a power outage, that might hit both of my data centers. So in this case, we can build multiple instances that will work independently, but still manage them from a single pane of glass. That's something that we call federation. You will see it in just a few seconds. But just a few words about the stretch cluster. We've got some requirements when it comes to stretching vSAN cluster. And this requirement is that we need to stretch management workload domain first. Having said that, if you want to use it, you need to stretch the management workload domain first, and that's going to imply the requirement of 4 hosts rising to 8, because you need 4 per site. So as you can see here, I've got 4 in availability zone 1, 4 in another. Of course, we need to consider witness, but that's something that we need to consider anyway. So that's another fixed design decision that will have an impact on your design. Federation, on the other hand, is a feature. It's a very nice feature, because if you know enhanced link mode in vCenter, that's something very, very similar. It's not intended to give you any higher level of availability and redundancy as such. It's going to give you a single pane of glass. So you can see on this lovely map that you've got multiple data centers across the world. They join the federation, and I can manage everything from one place right now. So that's a very good use case if you've got multiple data centers. A few terms that we should be aware just quickly is something called host commissioning. Host commissioning is an operation where we are adding SXI host to SDDC manager. That's going to be a day 2 operation when we are, or maybe day 1, depending on your life cycle, when we are adding new resources to SDDC manager to make them available for new workload domains or new clusters. SXI host must be installed. You have to do that. Then you are adding them to SDDC manager. SDDC manager is going to do kind of magic, verify that they are compliant with the standard, that they've got everything they need, that the hardware is compliant. If you are going to use vSAN, that there are enough disks for cache and capacity. And based on that, we can go forward and create a workload domain. That's, again, we will trigger a process from SDDC manager, which is going to create new vCenter, which is going to, based on your choices, either configure a vSAN storage or connect to existing storage, either VMFS or NFS, or whatever you want to use, and configure everything. If you decide that you want another NSX manager, fine, it's going to do that for you. So again, after some time, let's say 1 hour, you will have another building block in your environment that's managed from the same console. And that new vCenter, which will be created, also will be connected with other vCenter servers. So still we've got a single pane of glass, even on vCenter level. Something that I also wanted to mention here is that we can leverage VCF Tanzu. VCF Tanzu, for those of you who didn't hear that buzzword yet, it's our way to run Kubernetes in a vSphere natively in vSphere environment. There are a couple of ways how we can do that. We can either use those vSphere pods which are mentioned here. So basically run pods with containers on SXI host natively along with virtual machines. So in the same environment on the same SXI host, I can have VMs, I can have vSphere pods with containers. Another option is to run Kubernetes clusters as virtual machines. So we'll prepare the environment, and whichever option we use, that's up to us, that's up to our requirements or developers' requirements. But the key point is that, again, SDDC Manager will help us to prepare the environment for that. Because by default, vSphere is not capable of running containers. We need to prepare it. We need to enable something that's called workload management or supervisor cluster. VCF will also automate this process. So that's a high-level overview of VCF operation. But basically, the key things that I would like to emphasize is that this is a product with additional tools which are going to automate initial deployment, bring a process, but most importantly, the day two operation. Because the initial deployment, okay, you do it once. I did the deployment, I got the environment, but now every 2 months or half a year or 1 year, doesn't matter what my schedule is, I need to patch and update it. And that's another problem solver, because I've got lots of customers who are never ever updating their environment because they don't have resources. I mean, human resources. They don't have time to do that. So the environment, as soon as we deploy it, it's staying on the old version, which is definitely not a good idea due to various reasons. So we are missing features. There are security vulnerabilities which are not addressed. So that's something that we should avoid. And VCF is going to help us with that. And just in case you would like to play with VCF in the lab, you need to know that it's not going to be a easy tool that's used in the lab. And the reason is that it's quite resource intensive. Because first of all, you need to start with those at least 4 ASIC hosts. So if you are building a nested environment, you need 4 ASIC hosts with enough memory to put all those management components, vCenter, GNSX managers, SDDC manager, maybe NSX edges. So I use the traditional approach to build lab environments because I want the real scenario. I'm not going to cheat with any other tools when I do the deployment for customers. So roughly, I would say you need like 4 nested ASIC hosts with ideally at least 96 gigs of memory. Then it will work nicely. But if you don't have so much resources, or you don't want to bother yourself with all the prerequisites that we need to prepare for VISA, and not for VCF, like DNS names, NTP, entries in Active Directory, Active Directory itself, maybe from the routing perspective, if you want to leverage full capabilities of NSX, you should also have like a kind of virtual router where you can enable BGP, for example, and deploy NSX edges, and that's going to give you like full north-south communication. So that's quite a lot of work that we have to do in order to satisfy the prerequisites to build the lab. However, if you just want to play with VCF, there is something called VCF Lab Constructor, and here you can find some links where you can, first of all, download it. There is also a Slack channel where you can find help and information, how it works and how you can use it. But basic idea is that it's going to automate this part, which is going to create the supportive infrastructure for you. Active Directory, a kind of router configured on this Active Directory VM, DNS, NTP, DHCP, and DHCP is important. For VCF, you need DHCP in one network. That's a network used for NSX. Currently, this requirement was removed. However, if you are using Stretch Cluster, it's still there. So I'm just working on a deployment for a customer with VCF 4.2, but because of the Stretch Cluster requirement, we've got the constraint that we need to use DHCP. So that's Lab Constructor. Again, if you are looking, you've got some home lab or corporate lab and you want to play with it, that's ideal, I would say. And having said that, a few key takeaways based on my experience working with customers is, first of all, know your requirements and make sure that you've communicated also some of the fixed design decision to the customer. Make sure that we are on the same page. Because I've got a few customers who wanted to go with VCF. They made a, let's say, business decision that they want to automate stuff. And okay, VCF is a great fit for that. However, I've got a customer who ordered the hardware before, then they ordered licenses, and then they engaged me as part of the company to run the engagement, do the deployment. But they did a few major mistakes when it comes to the hardware design. First of all, they were not aware of the management workload domain. So now they are missing 4 hosts based on their sizing. They were also not aware of vSAN requirements. And in management workload domain, we need vSAN. So what they did the sizing, but they didn't take into account the need for cache disks. They were not aware that cache disks are not going to provide capacity. Apparently the name suggests this, but they were not aware of that. So again, they were now missing not only resources, compute, CPU, memory, but also some storage. Another mistake that was done there was the hardware sizing. They bought like almost 50 servers in total, and the hardware vendor told them, you know, the customer, if you buy the same config, that's going to be great because you will have a standard, which generally I do agree. However, they bought servers with 3 terabytes memory each. Do I need 3 terabytes memory for hosting the management cluster? Not really. That's huge waste, unless you put some other workloads in this management cluster, but that's a little bit conflicting to the previous idea. So that's another thing. Make your design from the beginning properly. Another haven that we've got with VCF is the requirement for BGP. Now it's changing a little bit and you've got more choice, but especially at the beginning, prior to version 4, that was a hard requirement. In order to provide north-south communication, or even not, that was just a hard requirement. During the bring-up process, you need to prepare and provide BGP as a dynamic routing protocol. And lots of customers didn't like the idea because they didn't have knowledge about BGP. They were using other protocols in the network, so they didn't want to use BGP, but they have to. Same like DHCP. DHCP must be there. Now, both those requirements has been relaxed because you can decide, do you want BGP or maybe not? There will be consequences of this decision, but you've got a choice. For DHCP, if you are not using stretch cluster, you can use full static IPs everywhere. But if you are using, if you plan to use and leverage stretch cluster, you need to use DHCP for one of the NSX networks. Not for all of them, of course, not for management, not for vSAN, but for one of the NSX networks. And one of my rules, 5P, proper planning prevents poor performance. This maps to the first point. If you do your job properly, you will have what you needed. But if you just, I will maybe pick this hardware because it's nice, those this because they are cheap, maybe it will be fine, but usually not. And the last point, NTP. I should put also DNS here. That's the most critical thing. It might sound cliche, but that's what it is. The majority of problems that I'm running into, especially in my lab, but also in customers' environment, is the lack of the type synchronization and incorrect or the lack of DNS names. VCF is extremely sensitive to that because we've got different products that must be reliable and must be able to talk with each other and be synchronized. So they are quite heavily dependent on that. So that's my key points that I wanted to tell you. So that's my official part. Now I'm going to take a look at the chats and what kind of questions we had there before I will pass it back. So can I use vCenter license but separately for different purpose to install VCF vCenter servers for VCF? So you can use it separately. You don't have to buy. VCF is licensed on the CPU basis. And whenever you purchase VCF, you purchase VCF for as many CPUs, sockets as you've got, plus vCenter instance. If you've got vCenter instance already, the license, you are good to go. You don't need to buy a separate one. That's not separate dedicated license for vCenter in VCF. And the next question, is vCenter license also similar to vCenter license? One vCenter license for all vCenter clusters on VCF? No, that's here there are no changes. So vCenter, when you buy VCF, vCenter is going to be integral part of your license. So this means that when you buy the VCF, you buy the bundle. You've got the license for ASXi, for the hypervisor, vSphere. You've got the license for vSAN and also NSX. And this is another reason why I always say that maybe vSAN is a good fit here. Let's consider it. Because anyway, when you buy VCF, you've got the license. It's part of the bundle. vCenter is separate, but all other components are part of it. And then depending on the license, whether it's standard, advanced, or enterprise, as soon as you go to advanced, you are also getting the vRealize suite bundle. But vSphere, so ASXi license, vSAN, and NSX is always there. And the next question that I can see, how can we provide redundancy to management domain if we are managing multiple customer workloads? So the redundancy to management workload domain, not sure which level we are talking about here, but first of all, we've got the redundancy on the server level. We've got at least 4 servers, and this is also not a random number. We've got those 4 servers for a few reasons. For example, NSX will have 3 NSX managers running as a cluster. This means that even if one of my ASXi hosts goes down, we still have full protection. The same for vSAN. vSAN technically requires at least 3 hosts, but in VCF, we need 4 for the management workload domain for very similar reason. Even if one of your ASXi hosts goes down, your data is still fully protected. Plus, we use the vSphere HA and other features that we can use. If you want, you can use fault tolerance. Whatever is supported in vSphere will be supported here with few exceptions. But as a rule, that's going to be purely the same vSphere. Or default storage policy in the management workload domain? Yes, definitely. So that's at the end of the day, it's an ordinary vSAN. It will be configured automatically. So some decisions will be taken for you, but as soon as it's done, you can create additional policies or even edit the default one. I would strongly recommend to not do that. Just if you need, create another one, not edit the default, but you can do that. And the FTT, that's basically the default policy. It's FTT equals 1. That's a standard typical vSAN policy.